Organic Chemistry of Caffeine and How It Applies to Life by Savannah Gibson. The chemical properties of caffeine are: its chemical formula is C8H10N4O2. The molecular weight is 194.2 grams per moles. The boiling point is 178 degrees Celsius. The melting point is 238 degrees Celsius. The pKa is 10.4 when it is at 40 degrees Celsius. The pH is 6.9 in a 1% solution. Its taste is slightly bitter, it is odorless, and it forms white prismatic crystals. And it has the properties of an organic amine base. The picture here is of the structure of caffeine. Solubility and classification. The IUPAC name of caffeine is 3,7-dihydro 1,3,7-trimethyl 1H-purine 2,6-dioene. It belongs to the heterocyclic compounds known as purines, and it can be classified as an alkaloid. The solubility, it is soluble in pyridine and pyrrole. Its solubility in water is increased by alkali benzoates, cinnamates, and citrates. In an aqueous solution of caffeine, salts dissociate quickly. The synthesis of caffeine. It can be prepared by the extraction of a natural source or by the synthesis of uric acid. The image below is of the synthesis from uric acid. As you can see, through the first reaction, it turns into xanthine, which then is turned into caffeine. The graph below is of the H&MR spectroscopy. There are 4 peaks in it. The first peak has 3 hydrogens, and it is off of the carbon labeled below by D. It is at 3.208 ppm. The next peak also has 3 hydrogens, and it is off of the C carbon labeled in the picture below. It is at 3.376 ppm. The next peak, it has 3 hydrogens labeled for the B carbon. It is at 3.877. And the third hydrogen peak is labeled with A at 7.884 ppm. The reason it's so far downfield is because it's connected to a carbon double bond off of an N. This chart is for the carbon NMR spectroscopy. The first peak in it is the carbon, one of the methyl carbons off of the N labeled in the picture below. The second one is the 7th carbon labeled in the picture below, also off of a nitro. The next one is the 6th carbon. That is the 3rd carbon. That's a methyl off of the N. Number 5 is the next one down, and it is off of, it is a carbon that has a double bond and is connected to an N. The next one, number 4, is the carbon that's connected to double bond to an N and then to another N from the other side with a single bond. The 3rd carbon is also in the picture below, that is connected to a double bonded O and 2 N's. The second to last carbon, which should be the number 2 carbon, is connected double bonded to another carbon, and 2 ends single bonded. The last carbon is a carbon that is single bonded to an N, double bonded to an O, and single bonded to a C. So the uses in everyday life: it is naturally occurring in most teas, coffees, and even some cola drinks. Coke even went so far as to put it in their naming as a brand. It can be used as a pharmacological agent. Its most notable effect is as a central nervous system stimulant, which is a stimulant for the cardiac and respiratory system. It is the most widely used drug in the world. It's added to most soft drinks, diet pills, and analgesics. It can be used to treat cardiac and respiratory issues, as I said before. There is also evidence that it can help with the symptoms or pain relief with migraines, and it can help lower the risk of gallstones. There are some issues where if it's used to excess, it can have adverse effects, such as giving you headaches and stomach aches and other things like that. And that's it.